Welcome to this overview of first grade Base 10 strategy development. Base 10 strategy development occurs in kindergarten, first grade, and second grade, and is the focus of targeted supports in each grade level. This video will focus on what first grade Base 10 strategies within 100 look like. So, the Base 10 strategy in first grade occurs through 4 stages: beginning, developing, approaching, and proficient. The beginning strategy focuses on number sense development, such as unitizing, that will then support students with the Base 10 strategies beginning in the developing stage. The developing stage asks students to add or subtract multiples of 10 to 2-digit numbers. So in this example, the second addend, 20, is a multiple of 10. Students represent these problems first by using physical Base 10 blocks. In this example, we can see that 56 is represented with 5 10 rods, 6 ones cubes, and then the 20 is represented with 2 tens rods. These physical representations are really important as students begin to develop their Base 10 understanding. We want them to flexibly be able to represent 2-digit numbers in blocks so they have a really strong understanding of what 56 represents. It's not 5 ones and 6 ones, it's 5 tens and 6 ones, and they can see here what that quantity really means. Once students are comfortable with these physical materials, they then will represent this same math using drawings that are more representational. So here it's the same math, but we have lines representing the 10 rods and circles representing the ones cubes. Another representation they use in the developing stage is describing numbers as blank tens and blank ones. So for this example, the sum, or the total number of tens and ones, we have 7 tens represented here and 6 ones. This can be clearly seen in the representations, as students could count the number of 10 rods and the number of ones. Lastly, we want students to represent their sums in a written equation. Next, we move to the approaching stage. In the approaching stage, we are asking students to add without composing a new 10. So you can see here, 12 plus 31. There will be no need to make a new group of 10. They add tens and then ones as one strategy. So we can see in this example, 12 is broken up into 10 and 2, and 31 is broken up into 30 and 1. The tens are added separately, followed by the ones, and then those two sums are added together to find our total sum. Note that this strategy involves writing out each equation horizontally, 10 plus 30, 2 plus 1, so that students can continue to make sense of the Base 10 structure. This also mirrors the way they've been using 10 rods previously, where they could map the connection between this is adding up my 10 rods when I was counting the 10 rods previously, and this is adding up my ones when I was adding my 1 cubes previously. Another example is we could have students add on tens and ones. So in this example, we only are breaking up 31, the second addend, into tens and ones. Starting with 12 plus 30, I add my tens first, and then I add on my ones. Both of these strategies, we want students to represent using equations, as seen here, as well as using the Base 10 blocks and Base 10 drawings. With all of these strategies, remember, it is important to regularly be making connections between strategies and making those connections visible for students so that they can see how their strategy connects to the next most sophisticated strategy. So if a student is adding tens and then ones using the Base 10 blocks, I would want them to then see how that connects directly to a visual drawing so they can move to that strategy. And if a student is using a drawing of Base 10 blocks, I'd want to map for them how that connects to this equation version so that they can try that strategy next. Our last category in Base 10 in first grade is the proficient category. In the proficient category, students are once again adding, but this time they are asked to compose a new 10. So in the example 37 plus 25, because 7 plus 5 is greater than 10, they will need to make a new group of 10. This is the most challenging of problem type that they're going to see in first grade, and it really relies on that base 10 strategy that's been developed throughout the previous stages of students understanding the relationship between ones and tens. In this category, they will use all of the same strategies that they used in approaching, but with this new equation type where they're composing a 10. And then they also can use the strategy of decomposing an addend to make a 10. So in this example, 37 plus 25, they can see that 37, to get to the next multiple of 10, they would need to add 3 on. So split up 25 into 3 and 22. I take that 3 and add to 37 so I can get to 40, and then I have 22 more to get to 62. That strategy can also be represented with the base 10 blocks or the tens and ones drawings as students make sense of it. Again, throughout all of the stages here and within the stages, our focus is on students seeing the connection between these strategies so they can use more and more sophisticated strategies as their base 10 understanding improves and preparing them for proficiently adding with composing a 10. Thank you so much for watching.